With practice at exercise 16.9 stutter, this is the normal way to solve the problem. If you haven't done it yet, don't spoil it for yourself. Look in that playlist link below the like button for the normal way to do it. Now, this part 2 is going to be to do it with recursion. So if you've already done it, this is what it looks like. Now let's do it with the recursion part. So I'm commenting all this out, and to do it with recursion, first let's start with our public void stutter method. Inside of here, we want a pointer to the front of our list. So we're going to make a ListNode current is equal to front. This is going to have the first value as well as the pointer to the next position. Every time we do recursion, it's going to kind of represent a loop in a way. And so that means that this while loop is going to be replaced with our recursion. Our recursion method, I'll just call it recursion. So let's say we have recursion and we're going to pass in our current front value, which would be this current. So current is going to be passed in. It's important that we pass in not just the value, but the pointer to the next value. And that's pretty much going to be it right there. Now let's code our recursive method. It's going to be a public void. Since we're not returning anything, we're just going to be modifying the list still, even though it's recursion. We have a public void. We're calling this recursion because that's what we called it here. We're passing in current. Current is going to be of type ListNode, so we need ListNode current, and now we can go inside of our recursive method. So again, it's replacing basically this entire while loop part. So we need to have a condition, always a condition inside of recursion, so we make sure it does not run on forever. As long as our current is not equal to null, I'm going to copy this just so you can see where everything is coming from. If current is not equal to null, a condition typically takes place for loops in recursives, where the loop is the recursion itself. So if current does not equal to null, we're going to be inside of here. And this is basically where all of this is going to take place. So inside of here, we still want to set our current.next, so the next value, to be equal to a new list node, where we basically copy the current data, which is current.data, and we have a pointer to the next, which would be the current.next. After this, we are still going to make a current equal to current.next next. I'll show you how you can do this a little bit simpler in a second. We'll just paste this down here because you need to do this part where you're basically moving the pointer, the current part, over two values. So instead of it being the front, it's going to be over one and then over one more. So it's going to be at this position. Now you have to do the recursion again. We just need to pass this value and pointer into our recursion. So instead of saying it equals, we can do recursion. We'll have a parenthesis here and a parenthesis here. And then we can finish this off and then finish this off. So we're going to close our if statement and then close our recursive function. Again, if we start up here, public void stutter, this is our original method. We're making a new list node, current equal to front, which is going to store this first value and a pointer to the next. Recursion current is basically going to be passing in that value and the pointer to the next inside of this method here. Now inside of this method, we are going to run this as long as our current is not null. So as long as this next value exists. If it doesn't exist, it's going to hit our base case and just unwind and return. So if current is not equal to null, we're going to have current.next. So this next value is equal to a new list node. So we're essentially going to say that, pretend this is empty. We set our next pointer value to current data, which would be what we're holding here, 1. And then we do current.next, meaning that we're going to have a pointer to the next value. And then we want to be at this value. Remember, we're still looking at the front right here. Current is still equal to front. We never set or reset the actual current value. So we're going to have to reset that in here by doing current is equal to current.next next. But since we're using recursion, we can just pass in current.next next instead of setting equal. Let's submit this, and that will also pass 5 out of 5 tests. And that's how we would do this practice it problem. If you have any questions, as always, leave them in the comments below. And if you want more practice it, they're in that playlist link below the like button.